I travel a lot, and sometimes I forget my charger, and so I'll have to buy just a random charger off the market. And so what we actually did was we got a AT&T charger, and it's pretty noisy. And you can see that using the same application that we just showed you, this is a Motorola solution using an Atmel chip.
Okay.
And as I'm moving my finger around, it works just fine, right? It's a touchscreen, but once you plug the noisy charger in and it starts charging, you can see as I'm moving my finger, it's jittery, and then you see that
jumping around.
Yeah, it's jumping around. It thought there was another finger when my finger's not actually there, and it just gets very noisy and jittery. So that equates to a very poor performance. So just me holding my finger there is just skipping around and thinking there's other fingers there. So if I do the same thing on the HTC One X, which is our solution, without the charger, it's tracking just fine as usual. And let me plug the noisy charger in. So now it's plugged in, it's charging. And then move my finger around, and it's really no difference between when it's plugged in or not. So this is just an example of when you have something that's very noisy and you inject it into the phone, it's tricking it into thinking that there's fingers there or there's other things going on that's not actually there and happening.
So how do you guys accomplish this reduction of noise or complete cancellation of it?
Yeah, so there's multiple things we're doing. There's things on the chip, for example, that we have special firmware and algorithms to be able to whittle that noise around. Well, we either prevent it from coming in, or if it does come into our chip, we have firmware algorithms to detect that noise and then suppress it. We also have a lot of sensor design techniques that we built into that sensor to also be able to block some of that noise from getting onto our touchscreen.
This is the multiple years of decades of IP that we've invested in this technology.